Big data is revolutionizing the world of IT industry, and according to Forbes analyst estimate, upward of 80% of the enterprise data is unstructured. Unstructured data cannot always be handled in real time. If we try to store this data in our RDBMS, do you think it will be able to scale up the data in real time and give 100% performance? Obviously not. This is why we require NoSQL databases in order to store and handle this data in real time. In this video, I will be comparing the different NoSQL databases: MongoDB, Cassandra, HBase, and Neo4j. First, let's understand what is NoSQL database and then dive into the comparison. NoSQL database is also known as not only SQL database, and it is an alternative to SQL database which does not require any kind of fixed table schema unlike SQL. It generally scales horizontally and avoids major join operations on the data. NoSQL database can also be referred to as structured storage, which consists of a relational database as a subset. Not only that, it also covers a swarm of multitude databases where each of them have a different kind of data storage model. What is the need for NoSQL databases? Compared to relational databases, NoSQL are more scalable and provide superior performance. Few of the solutions provided by NoSQL databases are: it can scale out the data easily and has a share nothing architecture which is capable of running on a large number of nodes. Next, it can scale and replicate thousands of machines with distributed data, and the architecture of NoSQL database provide higher performance per node than RDBMS and has a schema-less data model. Let's see what are the types of NoSQL databases. There are 4 different types, and they are: first, key value store. It has big hash table of keys and values, for example Amazon S3. Next is the column based store. In this case, each storage block contains data from only one column like Cassandra and HBase. Next is the document based store. Stores documents that are made up of tag elements, for example CouchDB or MongoDB. Next is the graph based. In this case, a network database uses edges and nodes to represent and store the data, for example Neo4j. These are the basic fundamentals of NoSQL databases. Let's jump into the comparison and compare the 4 prominent databases based on these parameters. First, let me introduce these terms to you. Cassandra. Apache Cassandra is the leading NoSQL distributed data management system that drives many of today's modern business applications by offering continuous availability, high scalability and performance, strong security, and operational simplicity by lowering overall cost of ownership. Next, MongoDB. It is a document-oriented database. All the data in MongoDB is traded in JSON format, and it is a schema-less database which goes over terabytes of data in the database. An Apache HBase is a NoSQL key value store which runs in the top of HDFS. HBase operations run in real time on its database rather than the MapReduce jobs. Next, Neo4j is a graph-based database management system designed to efficiently store, manage and query highly connected data. It's particularly adept at handling complex relationships and interconnection between data points. The core of this database is nodes representing entities and relationships between nodes representing the connections. Let's see the data model of these databases. Cassandra is a wide column store model based on the ideas of big table database. It consists of key spaces, which is the outermost container in Cassandra, and column family contains an ordered collection of rows. Next, MongoDB is a document store architecture with data in MongoDB has a flexible schema, documents in the collection. They don't need to have the same set of fields or structure, but common fields in the collections document may hold different types of data. Next, in case of HBase, It is partitioned into tables, and tables are further split into column families. Column families must be declared in the schema and grouped together by a certain set of columns. That is, columns don't require schema definition, and HBase works by storing data as key and value. Next, in case of Neo4j, it follows a property graph model. It consists of nodes, relationships, and properties. Nodes represent entities, relationships represent connections between entities, and properties are key value pairs associated with nodes and relationships. Now let's see the CAP theorem and see where these databases lie. CAP theorem is a concept that a distributed database system can only have two of the three, that is consistency, availability, and partition tolerance. CAP theorem is important in the big data world, especially when we need to make trade-offs between these four databases based on our unique use cases. In case of Cassandra, it has a decent-less architecture and any node can perform any operation. In this case, it provides A and P from the CAP theorem, that is, availability and partition tolerance from the CAP theorem. MongoDB and HBase provide CP from the CAP theorem, that is, consistency and partition tolerance from the CAP theorem. Neo4j provides consistency and availability from the CAP theorem. The next parameter on the list is the implementation language. Cassandra, HBase, and Neo4j are implemented using Java language, and MongoDB is implemented using C++. Though these databases are implemented using the object-oriented concepts, it also provides a wide support to all other programming languages. Next is the query language. As like SQL, Cassandra has its own query language called Cassandra Query Language, and MongoDB is queried using dynamic object-based language and JavaScript, and HBase can be queried using MapReduce. Neo4j is queried using its query language named Cypher. When it comes to performance, it should be noted that there is no single winner among the top NoSQL databases. Depending on the use case and deployment conditions, it is almost always possible for one NoSQL database to outperform another, and yet lacks the competitor when the rules and engagement change. Comparing on the benchmarks of performance, Cassandra is more durable and performs slightly better among the four. The next parameter on the list is security. In security, all the four NoSQL databases are secure in their own aspects. Like Cassandra and MongoDB, HBase, and Neo4j provides client authentication. Next, competitive advantages. For failure handling in Cassandra, every node contains a replica, and in case of failure, the replica takes charge. So there is no chance of failure, and it ensures 100% availability. It also offers lowest total cost of ownership, and Cassandra is the best-in-class scalability and performance of NoSQL databases. Coming to MongoDB, by offering the best of traditional databases as well as the flexibility, scale, and performance that is required by today's applications, MongoDB lets innovators who deploy apps as big as they can possibly do, from startups to enterprises, for the modern and mission-critical MongoDB. MongoDB is a database for giant ideas, and HBase can store large datasets on top of HDFS and will aggregate and analyze billions of rows present in HBase tables. For online analytics operations, HBase is used extensively. In case of Neo4j, the native graph storage and performance. Neo4j's architecture is optimized for handling graph data, providing superior performance and scalability. Cypher simplifies querying graph data. Neo4j ensures data integrity and consistency through ACID and allows users to scale horizontally and vertically to handle large-scale graph datasets efficiently. There is a wide range of applications of all the four databases. Cassandra is used in Internet of Things, fraud detection applications, recommendation engines, product catalogs, and messaging applications. Twitter and Netflix are the top companies that use Cassandra as the database. MongoDB is also used in the Internet of Things, mobile single view, real-time analytics, catalogs, personalizations, and so on. Coming to HBase, it is used in medical to store the genome sequence and the history of patient data, and for storing match history for better analytics and prediction in sports, and also in order to store user history and preferences. Web uses HBase for better customer targeting. So these are some of the applications. In case of Neo4j, it's used in social networks and recommendation engines, modeling network topologies, dependencies, and optimizing performance. Fraud detection also uses Neo4j to identify patterns and anomalies in financial transactions. Knowledge organizing and querying structured knowledge representations, and in biological networks such as protein-protein interactions or gene regulatory networks. Let's also compare how data is queried in each of these languages. In Cassandra, which is a wide column store, it supports CRUD operations, secondary indexes, and some aggregate function. In the case of a time series data storage, this is how data is queried to retrieve sensor data for a specific time range in Cassandra. In case of MongoDB, which uses a document-based model, queries are performed using the MongoDB query language, which supports a wide range of operations like filtering, projection, sorting, and aggregation. For example, in case of an e-commerce product catalog, this is how data is queried to find all products in a specific category sorted by price. In case of HBase, which is a column-oriented database, it provides Java API for querying data. It's usually used with Apache Hadoop for batch processing and analytics. HBase queries often involve scanning over rows or columns of data. In case of a social media analytics application, this is how data is queried to count the number of followers for a user. In case of Neo4j, which is a graph database using a query language called Cypher, Cypher is used for querying relationships between data points. In case of a social network analysis application, this is how data is queried to find friends of a user. So, I hope you've understood the differences between MongoDB, Cassandra, HBase, and Neo4j. Depending on the requirements, you can choose one among them.